So the question today is this one, which I had posted earlier on this page. Here we have 1-methyl cyclohexene reacting with KMnO4, that is potassium permanganate, and we have to give the product here, and this is a mild oxidizing agent, that is chromium trioxide in acetic acid. It gives this compound. So let us see the mechanism and also comment on this mechanism. The reaction scheme that is given in the question is this. Here you can see this is potassium permanganate. It is one of the most powerful oxidizing agent. And your chromium trioxide in acetic acid is relatively a mild oxidizing agent. Even though your potassium permanganate being one of the most powerful oxidizing agent, it does not oxidize your alkanes and aromatic compounds. So if you see a compound like this, where you have an aromatic benzene with some other group attached to it and you use KMnO4, then you usually see that your benzene ring is not touched at all and you get a carboxylic acid like this. Yes, now if you take an alkene, what happens? Your KMnO4, it dihydroxylates the alkene, the double bond, and we get two OH groups, that is cis 1 2 diol. Cis means this OH and this OH will be on the same side. That means when this potassium permanganate reacts with this, what we will get? We'll get a dihydroxylated product. That means when this reacts with KMnO4, the product that we get is Me and OH and OH. This is a glycol. Now let us see the mechanism. You can see here the reactant that is given in the question, and this is the structure of this potassium permanganate. Oxygen will form a bond with this carbon will form a bond with this oxygen, and this pi bond will fall onto your manganese. Here the oxidation state of manganese is +7. Now what is the intermediate that we get is this. Here the oxidation state of manganese changes to 5, and when we base hydrolyze this intermediate, we get OH and OH and Me. So this is the mechanism how we get the glycol. Now let us see how the chromium trioxide will react on this glycol. Now you can see here, this is your tertiary alcohol and this is your secondary alcohol. Now the chromium trioxide will oxidize the one which has one hydrogen attached to it. The carbon which has a hydrogen attached to it is the one which will be oxidized by chromium trioxide, and not this one because there is no hydrogen present here. Because we know oxidation, what is the meaning of oxidation? It is the addition of oxygen and removal of hydrogen. So if there is no hydrogen present here, how are you going to remove a proton, or how are you going to remove a hydrogen? So oxidation usually does not take place with a tertiary alcohol. Now let us look at the oxidation mechanism by chromium trioxide. What happens is your lone pairs of this oxygen is going to attack on this chromium, and your pi bonds will go to oxygen, and the intermediate that we are going to get is something like this. Yes, this oxygen is now positive and hydrogen is attached to it, and then chromium is there now, minus double bond O and double bond O. Now you see this will take up the proton here and it will give its bonding pairs to oxygen since it is now electron deficient. It fulfills the octet, it gives the bonding pairs to oxygen and fulfills its octet, and what we get is here chromium, here OH, double bond O and double bond O. Since we are hydrolyzing it with a base, this base will abstract this proton, this bonding electron pairs will go to oxygen and form a double bond, and chromium will leave. So this is what we get. This is OH, Me and the ketone. So this is the product that we get in the question.